the other one is Internet Protocol version 6. What happened to version 5? So when there are some standard development discussion going on, you'll see sometimes they have some conversation that doesn't get the maturity, doesn't get the acceptance. So yeah, anyhow, version 4 is the IP address that usually previously people have been using alone, but now because the internet is growing bigger, more and more users are adding to the internet, getting added to the internet, more and more new countries, new areas, they are starting using the internet. So the internet population is getting very big. But the number, like I said, number has to be unique. We don't have that many number in IPv4 address. So now there is a problem of shortage of supply of the IPv4 address. That means we need a different numbering system, a bigger number. So that's why the IPv6 address has been introduced. And it's already several years, like maybe already 2 decades already that people are people have started using IPv6. So you can say current internet is a combination of both IPv4 and IPv6. The IPv6 uptake or the usage may be slower to some countries and maybe in larger amount in some other countries. For example, in Timor-Leste, the IPv6 address usage may be not that like big, but there might be other countries who are using IPv6. And at some point, maybe Timor-Leste also needs to move to IPv6 as well. It's not like you have to stop this and start using this one. You can run both together. Layer 3 device, like I said, router, sometimes called a layer 3 device. It basically sends the packet towards the destination. So you pass a router, means you are closer to the destination. You pass another router, you are even more closer to the destination, something like this. So there are 3 specific tasks that router does. Very, very specific task. One is exchanging network information. Whatever I know, I'll tell my neighbor. Whatever they know, they will tell me. And this way we share routing information, means we share how to reach someone. For example, if I know somebody, some other person can ask me how to go to that person. So if I don't say this, that I know that person, nobody will know and they will not come to me, right? Similarly, you see advertisement in the television or in the boards. A company made a new product, they advertise it. Otherwise you don't know that they have that product, right? So information, if you want somebody to use it, you have to announce it. So in internet, a router announces the information that it has in its routing table. That means the information it knows, it will tell the neighbor, hey, you are my friend, keep my information to you. If you want to go those places, come to me, I'll take that places. So here is the opposite relationship. I have to tell the information, and when they use it, they have to send those to me, right? Routing information go this direction, really packet comes to the opposite direction. Similarly, if you see an advertisement, you have to go to that company to buy that. So the advertisement came from the company, but you have to now go to the company to get it, right? Same thing. So routing information and the packet flow in the opposite direction. Okay, so that's the exchange of information. This router needs to tell the neighbor what it knows. The neighbor collecting the neighbor's information along with its own information together, combining them, send it to the next neighbor. right? This way everybody knows everybody else's information. So that's the first task router does, exchanging network information, or you can say intellectual intel, the information you share with each other. The second thing is, once it gets all the information, it now need to find the best path to go to those destinations. This neighbor is telling me it can take me to a person. The other neighbor is also telling me they can also take me to that person. Now which path I should use? So I have to do an algorithm. I have to run an algorithm to find out the best path. The rest of the paths are my backup path. I'm using one or maybe multiple paths that's sometimes called equal cost path. If I can go this way and that way, both taking the same time, and both are same kilometers, I can take any path. That's equal cost path or equal path. So router finds what is the best path for you. Like I also said, network engineer can change that decision, that can manipulate that decision. For example, if Google Maps shows you a best path, you can take a different path, right? If you know that's better, you can go that path. That's the same thing. Router decides the best path, but then you as a network admin can change it as well. So it's not like hard and fast, like you cannot change it, not like that. So second task, so first task is gather information. Second task is sort among the information and find the best path and put it in the routing table. So that your routing table or forwarding table, sometimes called as forwarding table. So the forwarding table has the best path. And the third task is finally, if a packet comes to me, I'll use that forwarding table, forward the packet. So that's the real forwarding of the packet. User's data you forward to somebody else. So that's like in action. So three tasks. You collect information, you figure out the best path, keep it in the forwarding table. When a packet comes, you check the forwarding table how to go, pass that packet to that direction. That's like a traffic police standing, or the traffic lights becoming red or blue or things like that. When to go in which way, right? It's saying that thing. Best path lookup, how router finds the best path. Okay. So it checks the destination address of the packet when this is the last task. Okay. So when a packet comes to me, remember my previous slide here, the IP header has the IP address or the destination address. So router will focus on that part, this green part. Here I have the information about the destination. Now my router needs to find out the path to go to that destination. Okay. So the router finds inspects the destination address and then looks up the routing table. Remember previously it has the routing table built already. Where are the best path, how the best path needs to be used. So it will try to match the destination address with the table and find out the exit interface. A router can have many interfaces. Which interface to use? For our laptop it's easy. Laptop has only one interface, maybe a Ethernet or maybe a Wi-Fi connectivity. Whatever connection you use, for laptop it's easy, only one path. That's why laptop does not need to go through all the big routing calculations unless you have a specific routes in the laptop. But router specially designed and built to do the routing job. So it has a forwarding table, it has several different paths, you connect cable to all the paths, and you have this neighbor in this interface, other neighbor in that interface is junction. It's like a junction. So when a packet comes, the router checks its header, try to understand where this packet wants to go, finds the header and it has the destination address, it consults with its its brain is the forwarding table. It talks to the brain, hey, this guy wants to go to that way, I can send it? And it will say, hey, pass the packet to port 20, because the best path is towards port 20. So it will just pass the packet to port 20. That is how it's gonna do. Now, if there is no match in the table, like I said, there is a table that has the best paths. If the path is not in the table, that's unknown to the router, right? Usually, if something is unknown to the router just drop the packet. Okay, if I don't know anything, I'll just drop the packet. For the switch, layer 2 switch, right? In the beginning I told you layer 2 switch, or switch is in layer 2. It works in a different way. If it does not know anything, it passes it to everybody. But for router, if it does not know the destination, it will drop the packet. It will not process it. Okay? And for that, there is a term that's called default route. What is a default route? If I want to go out of this room, which way should I go? That's the only path I have. So that's my default route. Doesn't matter where I want to go. Do I want to go to the beach here, or do I want to go to Australia, or do I want to go to my hotel? Doesn't matter. I have to use that road or that path. That's the default route. So if a router does not know any specific path, it should drop the packet. But if I want that it should not drop but use this path, that's called the default route. Okay? So it's sometimes necessary for the router to have the default route. Now remember, my laptop, like I said, it does not have multiple ports. It probably has only one port, which might be the Wi-Fi at the moment, or the cable you connected. That means for router to go anywhere in the world, needs to use that interface. So that is why in laptops we have default route, because that is the only path I have, and it's towards my gateway. Because gateway is more intelligent. It can take me to different path and take me to the destination using the best path. So router's default route. Can you tell me what is the default route looks like in IPv4? How the default route looks like? How you write it? 0, 0, 0, 0, 0, then slash what? Slash 24 or what? A default route, how it looks like? 0.0.0.0, 4 zeros, and then slash 0. Who said slash 0? Who said 0? Somebody said 0, I heard, but I don't know who. Who said 0? I have a gift for you. Yeah, I have a gift for you. Who said 0? Somebody said. I really have a gift for you, because you don't want, so I cannot give you. Okay, so it looks like 0.0.0.0 slash 0. That means the last 0 slash after slash, the last 0 means that many bits in an IPv4 address needs to be matched. Because it's 0, no bit needs to be matched. Everything is counted. Everything is in there. Right? So that's why a default route is 0, 0, 0, 0. And you will see in your laptops there is a default route. So if there is no best specific path, then it checks for a default route. If there is no default route, then the packet will be dropped. Okay? Because there is no other way to go out. It's just dropped. Now, how the best path is selected, what I said in theory, here is an example, and it is with IPv6 address. So let's say, and I understand I have some challenges understanding the IPv6 address here. I'd probably give an example with IPv4 here. But the next slide, next session is on IPv6. Even though we'll do all the labs in IPv4, but I want to give you a routing kind of background of IPv6. So you, next time when you do routing with IPv6, you are familiar with the addressing. Okay. So let me give an example here. This is similar to IPv6, but I'll give you an IPv4 example. Yeah, so let's say this is a compute, I have to, okay, trying to draw bigger. So let's say this is my PC, computer, and this is the server. Let's say this is nog.tl. This is the web, and I want to browse the website, okay? Let's say this IP address is just an example, 10.10.0.5. Can you see at the back, is it enough, like big enough? So 10.0.0.5, I would probably use the black color because it looks better, it's visible. Okay, now when I send the packet to a router, this router probably already collected the information from the neighbors, and it already probably have the idea how to go there. So let's say it has couple of neighbors, and let's say this neighbor is the best path to go to the destination. Probably there are other networks and finally goes and like this, and this one probably goes like this, but this one is probably the best path. Okay, so the router knows this one is the best path. Now let's say this neighbor is telling you 10. This one is, let's say, a 16. This one is, let's say, 8 would be the best, 8, and this one is, let's say, 16. So the first subnet, the first octet is covered here with /8. The 2 covered with /16. Those of you who might have limited understanding with IPv4 addressing, that's what I'm talking about. No need to go very deep into the technical part, but let's focus on it. Match the first 8 bits. It tries to match the first 16 bit. So based on these numbers, it decides how many bits I need to match. So if my router knows both of these routes, and this one is via the upper neighbor, this one is the middle neighbor, so it will now try to find which one is my best path. Is it my upper neighbor or the middle neighbor? It's the middle neighbor, because it is going to find this destination matching this IP, but it will look at this number. This first 8 bit is a match with this one. That means it's a valid candidate. This one has 16. It will try to find this 16 with this 16. It's a match. This one also a valid candidate. Because that has a longer match, so out of 2, this one will be selected as the best path. So that is how the longest match works. And in mathematics, it works like this. Numbers, and these numbers do a Boolean AND operation. The AND operation in the Boolean algebra, you'll see it has to be both 1 to get 1. So like 0. Candidate, because the first 32 bit, this is 16, this is 16, this is a match with my candidate. The second entry is also a match, but this time not 32 but 48-bit match. So every colon is 16 in IPv6, okay? So 16, 16 and 16, 48-bit also a match. How you find it? You do an AND operation. So this is your destination and this is the how many bit you want to cover. So 32-bit up to this point. If you do the math, it's a match with 200 on DB8 and that's 200 DB8. Second one also match, but I can now extend. This is the second example where I can extend to 48. You see 48 bit of a 1. And my destination's 48 bit is at the top. If I do an AND operation, it becomes something like this. Now this time I match 40 up to 48 bit. Instead of the previous one, 32-bit, this one is a longest match, a longer match, right? So this one will become the best path. Same thing goes here with IPv4 addressing. On the control and data plane, if a packet comes, it will either get dropped or get processed. That usually is nowadays, that usually is getting done here on the data plane because it's data. For reason I learned from this neighbor, so I'll pass it to that neighbor. So that's called routing. As you can see, the routing flow from that network will go in this with this green arrow to this AS, then this AS, then number. I'll come to what is an AS number later in the next slide. But that's basically I'm saying, hey, I know this destination IP. If you want to come, you can come to me. Just keep that information in your table. So this network send this information to this neighbor. This neighbor means this router. So the router received it and remembered that the destination IP is reachable via that neighbor because they just told me that they can take me there. The router now is going to spread this information to all the neighbors, so internal neighbors and external neighbors. This information comes to this router will remember it, keep it in the routing table. And remember that if I want to go to that network, I have to pass it to my neighbor because the neighbor told it to me. Okay, it doesn't know how to go there, but it knows how to go there because it has a direct connectivity. Same thing goes to this neighbor sends to this neighbor sends to that neighbor, and then finally comes here. So now when the packet comes to this router knows that to go to that destination, I have to go here because actually that information came from that neighbor. They know that, so I'll just send it to them. That means internet routing works on rumors. Nobody is going to check that the neighbor is lying or not. If somebody lies, then your packet goes to that way and end up in a wrong place. That's why in internet, it's a shared responsibility of the network engineers. It's important that everybody configure their router nicely with the valid configs, with avoiding mistakes. Try to minimize the mistakes, and because if you make a mistake, that's probably gonna harm a couple of other networks as well, not only your network but also neighbors. In some cases, it harms, it creates problem for the whole country. In some cases, it creates problem for a whole continent. In some cases, it creates problem for the whole world. So it's not that easy. Internet is a kind of a shared responsibility. Everybody needs to do their best to make it safe. So I already covered the theory. So you have the different types of information, how one is For example, if here in Timor-Leste, if there is a commission, I think yesterday I was walking in the evening along the river, along the sea side, and then I saw anti-corruption commission building somewhere near the lighthouse. Yeah, there is like anti-corruption something like this. Yeah. So that's a commission, right? That's an autonomous body. Even government does not. I'm not so sure I should talk about government here, but in some countries, government does not interfere to the commission's work. They're autonomous. They have their own policies. Okay? So that's an autonomous system. They have some certain administration to decide what to do and what not to do. And they have a boundary as well. They don't go and interfere somebody else's network or somebody else's system. So, autonomous system is a system that is under a single administration, and they don't interfere others don't interfere them. In internet, it's basically a company, a network company, an ISP, a telco. They have their system, like so many routers, servers that are administered by the team. Not other team comes and fix or do this kind of things. They have their team. Now, in internet, what one autonomous system is one internet company or internet provider. That company is identified by a number that's called autonomous system number. If the Anti-Corruption Commission has some ID or number or something like this, if people know this number, they might say that this is the commission's number or something like that, but I don't think they have it. But in internet, a company, for example, Timur Telecom, in the internet world, they have a number. And that number is unique, nobody else has that number. That's how we understand the whole company's infrastructure. Because they might have 1,000 routers, right? All of them together identified by one number. And when I talk to my neighbor, when Timur Telecom talks to the, Telemore, for example, the other company, Telemore. And there is another company, Telkomsel, from Indonesia and also here. So Telkomsel, for example, we three wants to connect to each other. I'll tell, I have 1,000 router. What I'm going to tell to that company? I'll tell my autonomous system number so it understands this whole network is mine. So they will tell their autonomous system number so I understand I'm talking to that AS number. So in internet, a bigger number, like in a bigger sense, an autonomous system number basically identifies the whole company or the internet provider. So here, this is Bhutan Telecom. They have probably, let's say, couple of hundreds of routers and identified by AS number. And here in this example, we use we use the characters like ASN, but in real world, it's a number like 1, 2, 3, 4 or something like this, okay? So this is called AS or autonomous system, ASN or autonomous system number, something like this, okay? So it's your job now to identify your number. What is your company's AS number? First of all, not everybody needs to have a number. If you don't have a number, the only difference is you cannot now uniquely identify yourself or your company as an entity in the internet. But that does not mean you cannot use internet. For example, I'm a small ISP. In some countries, there are like small ISP, customer of big ISP. And that big ISP has AS number. So they have their connectivity up in the hierarchy, but they just give me service. I don't have a physical, I don't have a routing presence in the world. So nobody can find me. They will find my upstream provider, and then that will come. That's okay. I don't need AS number. But if you have a AS number, it's better you know your AS number. Okay, traffic. I told you traffic and network info, they flows in opposite direction. Which one goes first? I told you that traffic means packet, and the network information that flow in opposite direction, like the advertisement. Which one go first? Which one has to go first? Is it the traffic go first or the network info go first? Traffic. If you don't know where to go, network information exchange, network information needs to go first. And then router builds the table. And then if traffic comes, I understand why it is confusing. Actually, the network information is also traffic, right? It's also traffic. But here, by traffic, I mean the data packet, the packet for the users. So the network information or this routing information goes first. You have your understanding of the whole network. Now the packet, if the packet comes, you can now process it and send it to the right path. So here, within the AS number, means within the same company, one neighbor talks to the other neighbor. They build the routing table based on the advertisement. If I send something, they need to accept it. If they send something, I need to accept it. Now, sending and accepting is not the same thing. I can send many information. My neighbor may not accept everything. If I don't accept, it's not going to my routing table. If a neighbor sends me something and I as a network admin configured but that accept this, everything else just deny. Then only that information that I accepted goes to the routing table in my brain. Rest of them I just ignored, right? So it's important to accept. When you accept, you are already compromised. Means you now have to give this to your routing table. You have to follow with the routing process, and if they're the best path, you just pass it to them. So there is a responsibility. Vulnerable to mistakes. If they make a mistake, I'm going to suffer as well. Okay, so in some cases we have to think about it. Now here this is two different companies. That's called external relationship. This is called internal relationship. Similar thing, I'll send some information to my neighbor. They will accept it. If they accept it, that goes to their routing table. That means now if somebody wants to come to me, that packet comes to this router, it will pass it to me because I told the information to them. So the packet will now come to me. This already covered how this routing works. Now, for the routing policy or the manipulation, I said admin can select the best path. If you manipulate inbound routing info, that will manipulate your outbound traffic, opposite direction. If you manipulate, let's say this is my best path, but I don't want to take it. I took this best path. That means my upload traffic is go this way. So if I manipulate incoming routing information, I'm actually manipulating outgoing packet. So upload control means you are actually controlling the download routing information, incoming routing information. Okay? You get the point? That's the summary of the whole discussion. If this slide is not clear, then I have to go back and represent. So if I say like this door is going to ANC and anywhere else go from here, from this direction. There is no door here though, but let's say there is a door, okay? To go anywhere else. This is only towards ANC or towards the MTC. That means now when you really want to go, that information has to come from MTC side, saying you can use that door to go to MTC, right? So this information has to come from their side so we can go that way when necessary. That's like upload manipulation. if I say something to my neighbors that I know this network, I'm saying this to my neighbors, all my neighbors know about it. Now, when they want to send traffic, they will send traffic to me. That's my download traffic because my advertisement was upload or outgoing advertisement. So it's just opposite relationship. Like I said, there are two types of relation. One is internal, the other one is external. And based on that, there are some protocols. What is a protocol? Protocol are some rules, set of rules, how it works, right? That's the protocol. So interior gateway protocol and exterior gateway protocol. Interior gateway protocol are the, so first of all, what is a protocol? That's important. Like I said, my routing table has information to go to which interface, to go to that destination, use that interface and things like that. So it's a combination of a network and an exit interface. A network and exit. If you want to go to that network, take this exit. If you want to go to that network, take this exit, something like this. It's like an airport departure. Your flight number this, go to that gate. Your flight number that, go to that. And you check the television screen, right? You check the monitor where all the information, that's your routing table, right? Everybody is going to check that. They will take their route, okay? Now, if it is within your company, like I have 5 routers in this building and all are administered by our team, that's internal communication. And if I use a protocol so everybody can talk to each other and share the information, that's called interior gateway protocol. Now, if I have a peering with, let's say Timur Telecom has a peering with Telemo. So if they have a peering, that's an external peering. It's a little bit different. Internal peering or internal routing, you trust more because they are your own configuration. You manage the whole network. That means it's more trusted. When it is external peering, you follow different set of procedures because it's an external conversation, right? So that's called exterior gateway protocol, and we'll see the different options we have. So first start with the interior gateway protocol or internal protocols. Interior gateway protocol, what they do, they run within the same AS number and they are under the same administration. The IGP carries the infrastructure information. The protocol carries the network information, but what type of network information? I have my customers, I have my servers, I have my Wi-Fi network, different types of networks. Which information should be carried by IGP and tell the neighbors? The best way or the recommended way is to carry your infrastructure route. And infrastructure route, basically 2 things. There could be a little bit more as well, but basically for the time being, let's just focus on 2 things. One is called the loopback address, and the other one is called the backbone point-to-point link. This is very important concept. When you work in your network, you try to follow these recommendations, because this recommendation doesn't came from from a theoretical background. This came from years of working experience by big experts. They all agreed that it's better to set up your network like this. So your internal protocol will talk to your internal routers and share the routes. Now, what routes should be shared with your internal neighbors? Basically, like 2 routes. In one line, it's called infrastructure routes, because that's your own infra. And this infrastructure routes covers 2 things: loopback and point-to-point. And this point-to-point not with your customer point-to-point. This is your backbone point-to-point. Like you have one router, you have second router, there is a backbone link. That's a backbone point-to-point, not a customer route. So these 2 things should go to your IGP. So somebody can somebody tell me what is a loopback address? What is a loopback address? Anybody can anybody tell me loopback address? I think there are several network engineers. Physical, logical interface. Logical interface, that's correct. Local host. That's also correct. Anybody else? Identity of one interface. That's not very correct. Can you become more specific? I'm giving you some time. That's quite correct. Yes, this all three. You are like not really to the point, but it's all correct. All correct. That's I need a more accurate information. Yeah, you go ahead. Yeah, virtual interface of one router. I think it's correct. Logical interface, virtual interface of one router, the identity of the router, and you said the local host. Is all correct. It's like, again, I'm starting with the virtual portion of the. So you see a router has the physical interface. For example, my laptop has a physical interface, right? But it is physical, dependent on the physical network. If something happens to this interface, my laptop, I cannot contact anymore because that address is okay, but the physical interface is not okay, right? So, how can I say this? So let's say this room has 5 doors. Let's say just an example. If I physically, if I have to access the door, every door needs to be open. But if one door goes off and people doesn't have access in this room using another door, then they will just stand on the locked door and cannot come in. To avoid this, in router, let's say 5 interfaces. If I want to talk to the router with physical interface, and if there is something happens in that physical interface, I get lost. I don't get the connectivity anymore. But if I want to talk to the router using a logical interface, that's not dependent on any physical interface, but I need at least one physical interface to go and talk to that logical interface. So I'm basically taking an advantage, and all of them are correct. I'm basically taking. Okay, now I need like more energy. Okay, I need actually.
So let's say I just trying to explain the loopback address. So in Teton, maybe in local language. So kolega sirahatin saya mak loopback address ne oing instruktor explica ne. Sa oing kolega balon explicona, balon si local host, balon si identitas si router ne rasik. Ini bah hati loopback address ne IP spesial ida. IP spesial. Special IP da ia ne device ia address baninian rasik. Ini loopback address ne. Sida ni abel explica dan loopback address ia versão IP versão 4 nya no IP versão 6 ni hansa. Commonly usai loopback address ia IP versão 4 or IP versão 6 ne. Yes, Mr. Awal?
Yeah. So let's say this is my router and I have a couple of interfaces and I have neighbors connected, and let's say I'm here. I want to talk to this router. I want to get connected to the router. I can use this interface to connect because there is an IP here. If this link goes down, or there is a problem in this link, or somebody shut down this interface, I lost connectivity. But if it is like logical, and if there are multiple connections, like there are alternative paths, if I miss this connection, miss this interface, my router will not find it as best path anymore. It will try to reroute me to a different path, because I'm not using this interface. I'm using something logical in that router, not really physically dependent on the physical interfaces. Okay, so as long as the router is up, that interface is up. As long as the router is powered up, the interface is up. I need a physical path to go there. If my current path goes down, my router will talk to each other and try to find me a next best path. And this way, as long as there is at least one physical path available, I can still go there. Right? This is the benefit of having a logical interface. So that's why we usually have the loopback configured in the router. Even I have physical interfaces, I still try to do the, and that's why also he said to get access or talk to this router, that's an identity, right? To talk to that router. And we'll see why it is important, okay? Why it is important, we'll see in the lab. Yeah.
Kolega sila maklum kareta Avanza 13624 kali muda lalai tamatakaila ministrunia kareta. Iha ini Avanza viatura 13 Avanza 13224. Tanida. Karek. Oh.
Yes, thank you. So like I was saying, I was giving that example in this room. So let's say if you want to come to this desk, and if I just say come to the desk, and I say that instead of saying this, I say that door, come to that door, and that door is locked. So you will just go away. You'll think that this is not available. But if I say come to that door and use any of the doors, then as long as there is one door open, you can still come in. Right? This is the example that I was. So this is loopback, and the point-to-point is my routers. Let's say these are 4 routers. All are our company's router. These interfaces are the backbone point-to-point links. But if I have a customer here, this link is not my backbone point-to-point link. This is kind of an untrusted, kind of not trusted, not untrusted, but not trusted as I have my internal links. So these 1, 2, 3, 4, 5, these links can go to my IGP. That means this information can be shared within my internal network. What else? This is why we say that these 2 types of, or the infrastructure routes should be shared in your IGP, because IGP is a very important protocol, very important infrastructure protocol you need. I tell my neighbors what I know. If I know many things, I have more time needed to send it to my neighbors. They need to maintain a big table. They need to spend some time to calculate the best path. They will give a big table to the next neighbor. They will need more time, more processing time to find the best path, right? If after some time this link goes down, I have to tell my neighbor, hey, I told you before, I knew that, but now I don't know anymore because that link goes down. So change your best path. So it now needs to recalculate the best path. If you, in future, you make your business bigger, more routers needs to be added, you still can do that because your routing table is not big, okay? That's the benefit. Lower routing table or smaller routing table means you don't need to buy very big routers. Very big routers means expensive routers. Who is going to get the benefit? You are not getting the benefit. The vendors are getting the benefit. So if you make it if you make the routing with a good plan and minimize your routing table, that's actually helping you by, in terms of investment and in terms of processing the packet. So both ways it's a benefit. Now, have you heard about this OSPF? Who heard about OSPF before? Some of you mentioned this, right? OSPF. And then the other one is ISIS. Have you heard about this? Except the other ISIS in the newspapers. The Islamic State, that ISIS. There is interesting story. One of our trainers was doing the training on ISIS. So our company was sending some money to that person because of his work on ISIS. So now we are funding somebody who worked on ISI, who worked for ISIS, something like this. Anyway, so both of them they are actually two very popular interior gateway protocol. One is called open shortest path first, the other one is called intermediate system. So they have two different backgrounds, but actually they work in the same way. The protocols, what they do is you configure the router to tell what to exchange information. Your OSPF or ISIS will try to find other OSPF speaking router. If it finds a neighbor who also talks in the same language, they will start sharing routing information. They will say, hey, are you okay if I talk in OSPF? If the neighbor says, yes, I also understand OSPF. Okay, here is my network. I know this network. If you want to come, you can come to me. Keep it with you. The neighbor will also say the same thing. That way they will start talking to each other and sharing the information. Otherwise, a network admin needs to manually add those routes. That's called static route. And a static route is not scalable. If you have like 5-6 router, it's very difficult to maintain with static route. Dynamic routing protocol like this are very helpful to maintain smaller to bigger to very big network. I have to go to a destination and which one is the best, and keep the rest of them as a backup. If one goes down, they will use the next best path. So lowest cost or metric is the method with which it finds the best path, and it supports hierarchical routing. That means you can actually scale up your network in future because it has like area concept. And ISIS has something called level or routing, L1, L2 or L1, L2, 3 different structure. It has like backbone and non-backbone area concept. We'll not go very deep into it, but we'll talk more about the OSPF in our, I think tomorrow's slide we have OSPF. So next one is the exterior gateway protocol. It's called EGP. The previous one was IGP. That means this time I'm talking to another company. And now we need the AS number, right? Now we need the AS number. So there is, so exchanging network information between AS numbers, it is called EGP, and there is no variation, just only one protocol. There is one EGP that's called BGP, Border Gateway Protocol. For IGP, this is just 2 examples, there are others, but these are the most popular 2 IGP. But for EGP, you don't have any option, it's just only one, which is called Border Gateway Protocol. It's similar to the immigration, because you are now trying to go out to a different country. That's the border, right? Within the country, you have the other systems, but for similar thing, for one network to another network, you need to run a protocol called BGP, and it is the de facto because there is no alternative. Here is the hierarchy, or here is the, not the hierarchy, but here is the, is kind of a high level topology of the network setup. Let's say this is your company, your organization, your ISP. You have, let's say, 3 routers. This router connected to different networks. So this router knows some network, this router knows some network, this router knows some network. Now, if they don't talk to each other, how you know that to go to this network, you need to come here? How you know that? If they don't tell you that information, you don't know. If you don't know, you are going to drop. Remember, if I don't know that information, I'm going to drop it. That's how router behaves. That's why either network admin needs to configure this router saying, if you want to go here, push the packet to this router. This is very difficult because tomorrow there can be a new network. You have to configure another command here, another routing here. In future, if there is a new network, you have to do this also. Every single time you change something, you have to configure everywhere, because if I have a new network here, I need to configure this router to go this way, this router to go this way. If this link goes down, I have to configure this router to go this way. That's very challenging with a static route. Instead, if I configure with OSPF or ISIS, I can tell this router, this is my new network, can you put it in OSPF and distribute it to your neighbors? Then it will tell, hey everybody, I have a new update. This is a new network I know. Keep this information with you. If you want to go to that network, pass it to me. So this guy now got the information from the source. And not everybody now needs to configure anything, because I have a relationship with this neighbor. Whenever there is a new information, I'm going to get it. If I have a new information, I'm going to announce it so they will get it. I don't, as a system admin or network admin, I don't need to configure anything. At the beginning, I need to configure the neighbor. At the beginning, I have to make an arrangement to talk to each other. So this guy tells the information to the neighbors, it tells the information, and this way everybody shares the information. That's called routing exchange. Remember the first task, exchanging network information. Then this router builds a routing table for the best path. It's called forwarding table. Same thing goes here. So that is within the network, and that is why it's called IGP. IGP, Interior Gateway Protocol. Now, when you want to talk to the external, that means not in your ISP or in your network, you want to talk to other entity, you have a couple of options. You can use BGP, and BGP has two types again. One is called eBGP or external BGP. So this is a different company. I'm going to use external BGP. It's not complicated. iBGP or internal BGP and external BGP is not complicated. It's just whether the both AS numbers same or different. If this AS number and this AS number is different, that's called eBGP, because they are different network. If this router and this router talks to each other, that's called iBGP, because they are both same AS number. That's why there's no other difference. Now, you can have like upstream provider. Let's say I'm an ISP, my upstream provider is, let's say, Timur Telecom. So I have a eBGP. I have a customer. Which is, let's say, a bank or a university or a, let's say, office. They are my customer, or my home users. They are my customer. So I can run BGP or a static route or any other method, but not the OSPF or ISIS, because they are not my internal network. I'm not going to run. Remember, I should minimize my internal routing table. So I'm not going to give those route in my OSPF. Okay? Because if they have some problem in this link, my router will give an update to my neighbors. My neighbors will rerun the convergence method. For their problem, my router has to do with a lot of processes. Why I need to just do that, okay? And for the other types, you have IX. I'm not so sure if Timur IX is active. Probably no. So IX is where you find other ISPs. Instead of individually peering, everybody comes to a common point. I just maintain one connection. I get everybody else. You understood? Like that's called an exchange, telephone exchange. Telephone exchange, just like a telephone exchange. You come to, for example, this room. Instead of me going to everybody's house, you all come together here in the same place and we meet each other, right? That's the same thing, like ISPs, that they can come to a common location, bringing their fiber. They can connect to a router or a switch or whatever, and then they can just share information. Otherwise, they have to go, everybody's building. So many fibers, maintenance cost and other involvements. So this can also be done with eBGP. So this is like a picture of how a network, in like a high level, how a network works. And we basically gonna do this in the lab. So we'll first configure our IP addresses here. Then we'll run OSPF to share our network information. Two types of network with OSPF. One is loopback, the other one is point-to-point, backbone point-to-point. These two information we'll share in the lab, and then we'll see this guy tell the information, and if I log in here, I can see them. I can see them too. And same information, if I log in here, I can see. So OSPF will bring this scenario where everybody has the same picture. Okay. Everybody has similar information. Once we do that, then we'll do eBGP peering with our neighbor groups. So we'll do eBGP peering. This is how we'll do. And the last slide is again one more high level one. So here, one more high level. If you first run your OSPF, before the OSPF you configure your IP addresses. You configure IP addresses, you run your IGP, you run your IBGP, then you talk to another company. They also did the same, but you talk to them with eBGP. Okay, and now you have the question in your mind. If I run this IGP, why I'm running this IBGP? Both are internal. Why I'm running both? This is a common question and complicated, but we'll talk about it tomorrow, and then it will be clear, very clear. So you build your network first, then talk to your neighbor. They also build their network, and then now they are also ready to talk to their neighbors. So this is how the internet looks like. Every company do the same thing. They maintain their own network, and then they have the external peering with other companies, and that's how they are